Hello and welcome to third lecture in 13th chapter in our comprehensive course on AI, ML and DS. Now here we want to talk about this thing, that is comparison of two methods using PLT and using AX. Okay, so we created graphs in previous lectures using Matplotlib library, but once we use everything by single command plt.figure, plt.bar or plt.plot, whatever, then plt.xlabel, plt.title, plt.ylabel, and plt.grid if you want to show, and finally plt.show. So that is one approach which is called state-based approach. Okay, but another approach also we saw in which we initially initialize figure object, and AX object, axis object. So figure and axis both is equal to plt.figure, and inside we write fig size. Once they are initialized, all rest of the lines we were writing using AX object. For example, AX dot type of chart, maybe bar chart, okay, then or line chart, then AX dot plot, then AX dot set title, set underscore title, then AX dot set underscore X label, AX dot set underscore Y label, and ax.grid. Finally, we said that at the time of displaying the plot only, we again use PLT. Otherwise, we use AX, that is axis object, for all the plot creation. Now that approach is called object-oriented approach. Okay, and the advantage with that is we can create some subplots. So let us do a quick comparison. And again, this verbal discussion obviously is not very interesting, or some may find it a little bit difficult to understand, but we are going to take a code example immediately that will show the meaning of all this. So one advantage of state-based approach, that is using PLT throughout, is the simplicity. It is concise, easy to use syntax, and for quick and simple plot, state-based is very preferable method. State-based means what? That we did not define axis or figure. We can just directly start plotting. Lines of code are less. Even inside each line, the complexity is also less. So it is fast and effective. Disadvantage is that you have less control, and if you want to customize your axis, or you want to customize each of the figure, maybe you want to use different annotations for one subplot and another, then these things cannot be done. In fact, subplots themselves are not possible with PLT. So you have to write code for different plots one by one. Then customization is not possible. Adding multiple subplots, manipulating axes, fine-grained control over figures layout. Then, so that is why for many plots, this method is not suitable. That is, simple state-based method is not suitable. But when we want to use a quick, simple plot, then this method is worth going for. Okay, and if you want your plot to be highly customizable, you want to reuse it again and again, and you want to modify the same figure axis object for later use, then at that time, this approach is the better approach. That first, write instantiate fig and AX object by using plt.subplots, then ax.figure and fig size, then do everything using ax.plot type, that is plot, then ax.title, set underscore title, ax.set underscore x label, ax.set underscore y label, ax.grid, and finally again plt.show. That's all. Okay, so this offers greater flexibility. It is a complex but more flexible method. It gives direct control over each figure and each axis, and for complex visualization which require precise customization, this object-oriented approach is important. Then, if you need to create multiple subplots within a single figure, then this approach is useful. If you want to reuse the same AX object over next lines of or next cells in your Jupyter notebook, you can use this state-based approach. Then customization, if you want to plot highly customized graph, you can use that, and it can work with advanced feature, multiple axis, shared axis, subplots, and all. There is excellent compatibility. However, even that method, object-oriented, has its own disadvantages. The code is a little bit complex, more lines of code. So if you need more customization, you should go for it. But if you are doing ad hoc type of analysis, quick analysis, then state-based approach is better. If you are doing reusable analysis, then figure and axis object is better. Okay. Now, why teaching this is important? Because nowadays you can just paste your data frame like this. For example, this was your data frame somewhere. Yeah, this was. Okay. So you can just paste your data frame in ChatGPT or any other AI tool and tell it that give me Matplotlib based code for plotting line chart or plotting histogram or plotting box plot, and it will give you the code. Yes, fine. But suppose now your boss has asked me that I want all line chart, box plot, histogram, everything on the same horizontal axis. That is three subplots with one row and three columns, right? 1, 2, and 3. 0, 1, 2 if you want to write, but those type of columns. So at that time, you can again ask ChatGPT that instead of using state-based method, use object-oriented method and give me line chart, histogram, and box plot all on the same horizontal level. Then it will plot. But you will be able to ask it to ChatGPT provided you know that there are two methods with Matplotlib. That is the state-based method and object-oriented method. So nowadays, it is very beneficial for students that they don't have to remember the content of the lecture, but they have to remember the basic message given to the in the lecture, right? That from this lecture, what did you learn? And you learn that there are two methods. One is direct PLT based method, and another is figure AX. By PLT dot subplots, you create two objects and then do everything on that AX object, axis object, state based and object oriented. Thereafter, you don't have to go into the nitty gritty of coding much. You have AI tools, and there are free AI tools also nowadays. So you can just ask those AI tools for help, and they will help you plot the graph. Now here we are taking one example which shows the full power of that object-oriented approach. Because here I told this example that they provide greater flexibility and multiple subplots can be obtained, reusability, customization. I just speak from this whatever is already written here. That is not helpful, but if you should be able to see this thing. So let us suppose someone has given you this kind of assignment that a data set is given, which we will create here, synthetic data set. So that will be given to you, and it is sales for products across several months, and you want to write a detailed report with following figure. Two subplots are required, one which shows the sale for each product over time, and another which shows the percentage change in sales. Now this is highly complicated because even this can be done perhaps with simple state-based approach, sale for each product over time, but this is difficult to do. And here you can use the line chart, but there again plotting all the lines on the same graph paper, that may not be possible with the state-based approach, but that is possible with the object-oriented approach or fig and AX object you have to create, and you have to go on reusing the AX object. This percentage is involving some calculation, so better would be to use that fig AX method. Now here they ask that also not only give two subplots satisfying this condition, but customize the appearance, use different line styles, colors, markers, and labels. Put annotations at specific data points. For example, wherever highest sale month is there, then clearly annotate that point. Lowest also you can annotate. Legends. Each subplot will have its own legend for clarity, because whenever there are multiple plots plotted on the same graph paper, then each plot is giving a different message, and for each plot y and x axis are also different. So you have to clearly specify on the graph paper itself, on the subplot itself, that what is the legend saying, and grid lines should be there, axis should be there, tick marks should be there on the axis, etc. So first let us create the data frame. Okay, it is a data frame with product A and its sale from January to December, and product B and C again sales from January to December. Now you are asked create a complex plot. So we start with our usual step. First instantiate the two objects. So fig object comma AX object is equal to plt.subplot. Okay, and here you write how many plots you want to make, how many columns you make, how many rows you want to make, how many columns you want to make, and the fig size. That is the canvas on which the two plots will be plotted. What should be the figure size of it? So I am writing a bigger canvas, 14 pixel by 10 pixel, because I know that this would be a slightly wider plot, and also I want two plots one below another because two rows are there. So height also should be adequate, right? Share x is equal to true. Now that is because both plots are having same thing on x-axis, then you can share the x-axis. Similarly, if both plots have same thing on y-axis, then you can share the y-axis, right? So then this is how you can plot the graph. Again, as I said, code is not that important because you can always nowadays use AI tools, and from this chapter onwards, you are free to use AI tools even for exercise and everything. Okay, because such complex plots, AI tools can generate very nicely. Here we are using marker O, marker S, and marker this kind of caret symbol or cap symbol for this product A, product B, and product C. Okay, and these are the colors B, G, and R, and this is the line style, and this is the another line style. Now add titles, labels, grid, and customize the axis. So this will set underscore title, set underscore y level, grid, and legend. Okay, so that will decide this thing. Annotate the highest point for the product. Now for that you are even using this kind of f string, okay, and you are using some calculation, some variable also, that what is the max sale month. Then for product A you have to find the ID, that is month ID, for which the sales is maximum, right? And so on. So same code is there. You are even deciding ticks and rotating the ticks by 45 degree, so that just for the sake of better display. So let us see the plot, and you realize that it satisfies your condition. First of all, you started with this 2 rows, 1 column, and this is the fixed size, and x-axis should be shared. So you can see 2 rows, 1 and 2, right? 1 column, only a single column. X-axis is shared, so that is why January, February is written here. Here nothing is written, but that is also meaning that x-axis is same for both plots. Let us share x is equal to false. If I move, if I say that, if I make that false, then you can see now January, February are everywhere present. That is on both plots. Okay, so that is one thing. Now one another thing is here, instead of plots 2 rows and 1 column, I try to plot 1 row and 2 columns. Though that would be slightly difficult because this is yearly sale. So that is why if I try to accommodate both plots in the same row, okay, so then in that case they will be compressed like this horizontally, so become a little bit unwieldy. But you can see that this is the plot. Okay, now it is only 1 row but 2 columns, so that is also simple, correct? Now here instead of line plot etc., you can change the type of other plot, or here marker you can change. For example, product A, B and C you are showing on same graph paper, so you are showing by different color, B, G and R. So blue is product A, green is product B, and red is product C. You can also see that annotations are shown here along with the circle or square or whatever symbol. So here the marker is circle or oval, here the marker is S, and here the marker is triangle. So a nice annotation is shown for each graph separately. Here also the colors are used the same. So here product A is blue, product A is blue, product B is green, product B is green, and for product C is red, product C is red. So consistency, that math thing what I said about earlier, desirable properties of a good visualization. So you are using consistency of code or consistency of color symbol. Okay, then you can maybe try, yes, you are using the consistency in that, not consistency, but you are making your graph clearly distinguishable from each other. That is explainability and maybe accessibility, that qualities of the graph. Much earlier, if you remember, we had done these desirable properties: clarity, accessibility, consistency, relevance. Now when I did it both graphs on same row, I compromised with clarity, because as I said, the graphs are over entire year, so this was not very clear. So let me make it 2 rows again and 1 column, correct, and plot the graph. This is much clearer for each for both graphs plotted with sufficient width. So clarity is ensured this way. Then separation, accessibility is ensured by using different colors and different markers. While using colors, I am ensuring the consistency that on both graphs the color used for product A, B and C remain same. I am plotting only the relevant chart because I am asked to do one showing sales of product over time and other showing percentage change in sales. So I am plotting the linear chart for showing sales over time because that is the trend. So what this conveys is that for product A, blue, the trend is fluctuating in the initial part up to the first half of the year, but thereafter product A's sale shows a consistent improvement. Maximum sale is found at this particular point. Product B sale also is fluctuating, and it keeps on fluctuating throughout the entire duration of the year, and product C sale is also fluctuating almost during the entire duration of the year. So product blue, that is product A, has a different behavior compared to product B and C, that is red and green, right? Now percentage change, so on y-axis now percentage change is shown, and for each of the graph paper, each of the product, we have shown percentage change by a bar-like chart, so that it is clearly visible that largest percentage change occurs in which product. Then perhaps this graph is the longest, so, or no, this red is the longest, so largest percentage change occurs in product C. Okay, and minimum in which month? Then in July. Maybe green is also behind that red, so in product C or B also, that is green, the change is the largest possible. Okay, and it is also in July. In all three products, July month seems to be the month where the sales are peaking. P-E-A-K, I'm talking about, not P-I-C-K. So peak, their sales are reaching a peak value. Okay, so many things which were not visible from that data frame, this data frame. Or if at all you can identify such trends, you have to go through each column again and again and mentally think that whether sale is increasing, decreasing. Here, nothing is required. Plot the graph and everything is visible. And in reporting, percentage metrics are very important because businesses are always interested in that. I have used your data driven approach as you suggested as a data scientist. Now, what is the percentage gain? So suppose here they started using data driven approach. Initially there are some fluctuations because initially some model also needs to be trained and then retrained, and it needs time to adapt the whole organization to the data driven approach. But once July reached, you can see that percentage gain in the July month was highest. Thereafter, maybe the organization had just taken this as a pilot project, so it came back to its old ways of doing business. And you can visibly show the difference that when you do the business by your old way, then at that time the percentage gains are negative, because below zero line they are negative and they are smaller also compared to this case where they are positive and they are smaller also. So by the end of the year, you convinced your management that see the data of this 11 months, and you can see clearly that here we adopted the model. It took some time to adapt, but the result were immediately visible. Here we removed the model and we went back to our old ways of doing business, and the difference is immediately visible. So we redeployed our model, and now we have finally decided that we will use our data-driven approach only from next onwards. So for next month, you will only get these or this type of graphs. That is everything above zero and everything showing some positive percentage change in the sales of product A, B, and C. Right. So this is the graph which shows the real potential of object-oriented approach, that is Fig and AX. If I just insist that I want to write my entire code with PLT only, that is state-based approach, then I cannot achieve this level of customization. Okay. Now you will read this. What are the key features in the graph? I have explained almost everything, and then you will do this exercise. For the exercise, as usual, I have created this code which will first generate the data. Then you have to solve this question. Similarly, this is code for the next question. So generate the data first, and then you solve this question. So we will meet in the next chapter 13, and we know that this visualization will continue for next 4-5 chapters, correct? Okay. So we will meet you in next chapter. Thank you.